So this is a screenshot of number 5 and 6 off of Module 1, Lesson 3 quiz. And this question probably half of you missed it. So I wanted to go through and show you this because it will be important later on that we are able to correctly add vectors. The first thing that we need to do is we need to do some trigonometry in order to find, let me change to a different color, in order to find the value. By the way, you would not want to do what I'm doing right now on the AP exam because they do not like for you to represent vectors as, or components of vectors as really any type of line. They want you to draw them completely separately. And I'm going to color code these so we can tell the difference. I'm going to do blue and red, and I'm going to label these guys. I'm going to call this R1 Y. I'm going to call this R2 Y, and I'm going to call this R1 X. I'm going to call this R2 X. Okay, now I'm going to give you some samples of how I would set up the math here. So to find the value of R1X, I will need to multiply R1 times the cosine of theta 1. By the way, make sure your calculator's in degree mode. If you don't, it'll get ugly. Now, I gave you a different angle over here, or at least I gave you a different part of the triangle as far as where I picked the angle. So to get the value of R2X, it'll actually be R2 sine, because it's opposite over hypotenuse. That's sine. Cosine is adjacent over hypotenuse of theta 2. Alright, so I'm going to pause the video, do some math, and I'll be right back with you. Okay, you can see that I went through and I worked out the math for the rest of these components. Feel free to pause and look at it. Now, something that's really important to realize. You have to look at this stuff and see if it makes sense. And the thing that I would like for you to notice here is that this y component, well, it points downward. So the way that we indicate that is we will call it a negative 4.07. Now, what we have to do is sum up so that we can get our x and y components of these vectors. And so if I look at it, I've got an x component 9.57. Actually, let me go back and do this all in red, or at least attempt to be consistent. I'll just write over that. So I'll do my x's in red just to be consistent with what I've been doing so far. Plus 1.9. Okay, so I'll do that, 9.57 plus 1.9. And that's 11.47. Okay, so that's this part. And then the y components, 8.03 minus 4.07. And a little bit of mental math here. I think that's 3.96. All right, so overall we have 11.47 and 3.96 as our components. This is the x component, this is the y component. Now, once I get that information, there are two things I can do with it. One is find the magnitude of the resultant, and the other thing is find the angle. Okay, to draw what this looks like, it's an x component that's 11.47 and a y component that goes up 3.96. So that will help most of you all visualize what's going on. And what I want to solve for is the resultant over here. So that's a really simple a squared plus b squared equals c squared kind of deal. So I'm going to do Pythagorean theorem, pause, and you'll see it appear in just a second. Okay, so I did Pythagorean theorem and solved for r, so there's my value for the actual length of the resultant vector. Now the other thing that I was asked to solve for was the angle. So the angle, I'm not going to redraw this, but you can see that here's the angle. Okay, that's a simple matter of just doing a little bit of trig, and since we have the opposite side and the adjacent side from that angle, we're going to do inverse tangent. I know different people write that different ways. You might see arctan or tan to the -1, and then opposite, so 3.96 over 11.47. Once again, make sure your calculator is in degree mode and input that. And here you have it, final answer, 19 degrees, and that would be above the horizontal, because the horizontal would be like the positive x-axis. So there you go, and hopefully that clears up any questions so you can see how all that stuff works together.